Hello. Now I'm going to review homework 1. Like in this video, I will discuss question 1. It is pretty simple, a very simple model where x is scalar and there is an intercept. And we study what happens if we assume this equals to 0, like its mean is 0, or if you subtract the mean. And we have this. And most of the questions are pretty straightforward, but one thing is many students have struggled in A. The correct answer is by Jiao Hao and Hyunwoo. The answer should be this way. So like we have to check if this matrix is non-singular, or that matrix has an inverse, or if that matrix determinant is non-zero. To show that it is a simple 2 by 2 matrix, so its determinant is this. So you have to show that the determinant is different from 0, which is simply variance different from 0. So this is how you prove this. Simplest way to prove it. And another problem was in Iwei's answer. This is exactly what I don't like. We are discussing the population properties, but where is n? N is infinity in our argument. So you cannot define n like this. You cannot define n this way. So she's considering a pure finite sample argument, which is totally misleading. And so once you prove A, all the other questions are simple algebra. Most of you have done well. Some, like most of you are right, but some have a more clever way, simple and clean answers. But that's okay. And maybe the problem is, it's my problem. I screwed up in here. I want to, it is actually, this is not what I exactly meant here. So show that the full rank assumption is satisfied if this is non-zero. So the correct, like given this question, correct assumption is like this. In general, in vector case, the full rank assumption is that the matrix is invertible. It has an inverse matrix. But if x was scalar, this becomes a scalar 1 by 1 matrix, which is a number, right? Then a number has an inverse, means it's non-zero. So for any number, like you can take its reciprocal. So the full rank assumption is satisfied if it's non-zero. So same thing. So it's there's nothing to show, it's equivalent. So the question is wrong. What I wanted to say was that the full rank assumption here is equivalent to the full rank assumption in the original equation. So what I'm showing here is the meaning does not change anything. The full rank assumption, exogeneity assumption remain the same, and the only difference is the meaning here and no intercept. So structurally almost like exactly identical, does not change anything. Okay, I will it was shorter than I expected, but you did well. I'm going to do the next question in the next video.